Hello students. So today we are going to work out problems on this chapter, work, energy, power. This recent year questions, right? Let us start. This is the first question. Two bodies of masses are given, moving with equal kinetic energies. Kinetic energies are equal, right? The ratio of magnitude of their linear momentum. So what we can do, we can write kinetic energy in terms of linear momentum. Kinetic energy can be written as p square by 2m, all of us knows. If kinetic energies are equal, then p1 and their momentum is also, we have to calculate these ratios, right? So p1 square by m1 you can write, or if you want to, you can write p2 square by 2m2 you can write. Obviously this factor 2 will get cancelled and we have to calculate from here p1 by p2. p1 by p2 will come as root under, and this is m2, right? So root under m1 by m2. So root under m1 by m2 we have to do. So let's take root under first mass 4 and this is 25, right? That will become root under, when you do it will become 2:5, isn't it? So that's the correct answer, 2:5. Let us move to the next question. Next question, potential energy is given as a function of x, y, z, and x, y, z are in meters, right? These are positions. Now they are asking us to calculate magnitude of x component of force, okay, acting at point. So what we need to do here really is, we don't have to consider everything, only we need to consider differentiation, right? Because when they ask about force, so we should know the formula for force. Force is minus partial differentiation, right? I cap minus partial differentiation of u with respect to y, j cap minus partial differentiation of u with respect to z, k cap. This is what it is, and here we need to find only the x component, this one, and that to magnitude. So of course, let us first calculate fx on the minus partial differentiation means this term, which it is 2x square plus 3y cube plus 2z. This we are going to differentiate partially with respect to x. That means all other things will be constant. Yz is constant. So only first term we have to basically differentiate. It will become 2x square differentiation basically, right? So others are constant. So minus 2x square differentiation is 2x. So that is minus 4x. And we can substitute the values at 1. So if you take x is equal to 1, this x component becomes minus 4. And we need to take magnitude. So magnitude of f of x is just 4. Right? So that will be the correct answer, 4. So in this manner you can solve it. Okay, let us move to the next. A block of mass 100 kg slides over a distance of 10 meters. Okay, so there is a block, let us say, and this block is going to slide, okay, over a horizontal surface. That means the surface will be rough. Okay, let us say that this is the surface and it is going, it is moving over it. Okay, right. So mass is given. This is the mass 100 kg. Coefficient of friction of this surface is given 0.4. Okay, and it is going to slide at a distance of, let us say, it comes here and it has slide a total distance of 10 meters. So friction is of course acting backward, friction is going to act backward. So the displacement here, delta r, right? Forward, friction, backward. So what is work done by friction? First you calculate. Work done by friction is minus friction into the displacement. And work done against friction, they are asking work done against friction. So work done against friction is equal to negative of work done by friction. Okay, so that means negative will become positive. Friction into displacement, we have to just calculate. Friction is mu times normal, and of course normal is equal to mg, right? So mu mg into delta, this is what we have to calculate. So mu is given 0.4, mass is given 100. Let us take g approximately as 10. We can take that as 10, right? but the values, if you see, they are going to change. So I think we should keep it as 9.8. Let us we'll check afterwards, okay, because they did not give value of g. Okay, then displacement they have given tan. So how much it will come from here? Let's just calculate that. So from here, when you remove decimals, this 100 will go away, right? That means you will get 4 into 98 into 10 will be there, isn't it? So let's see how much it will be. It is approximately 2 and 9 into 4, 36, 36 and plus 3, 39, right? 3920. Approximately it is coming. That means we are taking g. If you take g as tan, let us say if you take g as tan, how much it will come? If you take it will be 1000 will be there, right? So 1000 and here 4000 will come, isn't it? 4000 will come if you are taking, but I think here they should mention the value of g. I hope g may be mentioned in this question. If g is mentioned, then we can just take this one, right? So work done against friction should be considered positive, right? So mu times normal friction and its displacement is 10 meters, right? So with this, if you go with this, then 3920, which is near to 3900. If you take tan, then it's going to be 4000 exactly. So let us take g as tan. If you take, I think g will be given in the question. So if you take this tan, then you will be getting 4000, isn't it? Let's move next. The de Broglie equation. De Broglie wavelength of electron is same as that of photon. So electron wavelength lambda. So what is the lambda? Lambda is equal to h by p. We are saying the wavelength is of electron is same as that of photon. Okay, the velocity of electron is 25% of the velocity of light. So velocity is 25%. That means 25 by 100 of the speed of light. So this becomes c by 4, isn't it? So this electron is moving with a speed which is equal to c by 4, and it has got wavelength, that is de Broglie wavelength, right? Okay. Now what they are asking, then the ratio of kinetic energy of electron and kinetic energy of photon. Okay, photon. So lambda of this electron is same as lambda of this photon. Both you can say that they are equal. Okay. Then how do we calculate the kinetic energy? We have to calculate kinetic energy of electron by kinetic energy of photon. So kinetic energy can be written as p square by 2m, isn't it? We can write it as p square in terms of momentum. Otherwise, half mv square we have to write, isn't it? So we can write this as p square by 2m. Now, what about kinetic energy of this photon? I think kinetic energy of photon can be just written in terms of the energy of the photon, which is lambda into frequency, right? Or that is the energy of a photon. Photon energy is what? Photon energy is hc by lambda. We can write it like this. Okay. So here let us try to write this. So p square by 2m will be this side, and this lambda will come in the numerator, and this will be next. Okay, so this lambda can also be written as h by p, isn't it? Or lambda by h is nothing but 1 by p. So p square by 2m, here lambda by h has become 1 by p. So there will be p here and c here. I think you can cancel 1 p, and this p is the momentum of the electron, p, and this 2m, c can be written as 4 times of p, right? 4 times p. So this p and this is 8 mv is also the the electron momentum. So this will get cancelled, it will become 1 by 8. So finally we are getting answer as 1 divided by 8. This is the ratio that we are getting. Okay, so option number 2. Let us move to the next question. The bob of a pendulum was released from horizontal position. So this is the bob, and let's say it is released. This is the center, and we are releasing this. Let us say we have released it from this point. Okay, this is the bob. Then what happens? And they have also given the length. This is 10 meters. If it dissipates 10% of initial energy against resistance, so when it is coming here, so energy is getting lost because of friction. So when it is coming here, it will have some kinetic energy, half mv square. Initially you have released, so the kinetic energy is 0. Okay, only there is potential energy, which is mgh. H here is nothing but this is the height of this from the bottom, right? Which is the nothing but 10 meters, because that's the length. So into 10, this is what is potential energy, and finally we'll have kinetic energy. So potential energy, let us make this as 0, because we can consider this height to be a reference height. So we take the potential energy here to be 0. Okay, this level you can take potential energy 0. So total energy is only kinetic here, right? So this total energy, kinetic energy, which is half mv square, they have told, they are saying that this is not same as the initial total energy. Why? Because some energy is lost. 10% is lost. So that means 90% we can equate. So let's equate 90%. 90% of this mgh, right? So let us now cancel out from here. Mass will get cancelled, and we can solve from here speed. They are asking speed, right? So v square. From here 2 into 90 by 100 into g you could take 10. This is also 10. So from here 100 factor will get cancelled, right? So we will get v as root under 180. You can see, we can write this as 180. Okay, now here we can try to break it into factors, isn't it? So 2 into 90. 90 can be written as 9 into 10. 10 can be written as 2 into 5. So certainly 2 will come, and 9 4 36 will come, and root 5 will come. So 6 root 5, that's the correct answer, isn't it? Option 1. Right? So as you will release it, it is going into circular motion, and this is the bottommost point. And obviously it is losing energy because of friction. Okay. Then let's move to the next question. A bob of mass m is suspended like this, suspended. Length of the string is given. All these things are given. It is imparted a minimum horizontal velocity at the lowest point, so that just complete half circle, reaching the top position. The ratio of kinetic energy. Directly will apply the formula kinetic energy at the bottom and kinetic energy at the top. Kinetic energy at the top. What is the speed at the bottom and top? We know that this speed at the lowest point is equal to root 5 gl, and this speed at the highest most point is root under gl. This we should note, because this is an important result for body to just go into a circle. That means it's the critical velocity, right? So this kinetic energy, write as half mv square. Velocity at a means this is lowest point, and this is also half m velocity square at the highest point, right? So they are asking the ratio kinetic energy of A by kinetic energy of B. Half m got cancelled. It is just the ratio of VL square by VH square. So VL square is 5 GL, and this is going to be just GL. So definitely this is going to be 5:1. That will be the answer. Yes, we got it correct. Option 2. Yes, let's move to the next question. So an artillery piece of mass M1 fires a cell of mass M2 horizontally. Instantaneously after the firing, ratio of kinetic energy. So it is just the example of recoiling of a gun. Recoiling of a gun. A gun, how does a gun recoil? So suppose that this is a gun. Okay. And it is just an approximate diagram. Okay, this is a trigger, of course. So as soon as it fires, so before that there is no momentum, right? Total momentum system is 0, right? Once it is fired, what happens is that the bullet is, let's say, like this, and this bullet is getting fired. This will recoil backward, right? So it will have equal momentum, then only the momentum can get cancelled. This is what we should know. Both the momentum of this should be same. They are asking the ratio of kinetic energy. Let's say the mass of this, piece, artillery piece M1 fires a cell of mass M2. This is the cell M2 and this is M1, right? So definitely we know that their momentums are same. They are asking the kinetic energy ratio. So kinetic energy of which? Artillery. Artillery means the gun itself, right? So let's take kinetic energy of 1 by kinetic energy of 2. So kinetic energy is P square by 2M. So P square by 2, its mass is M1. This is P square by 2, its mass is M2. So definitely this ratio of kinetic energy 1 by kinetic energy 2, we are getting this as M2 by M1, right? So we can solve this question just by momentum conservation concept, right? Recoiling of the gun. Okay, then let's move to the next. Now they have given that there is a mass, a body of mass m. I think some mass will be given. Begins to move under the action of a time-dependent force given by this. The power developed by this. So power. What is power? Power, if you see, power is nothing but instantaneous power is force into velocity, right? So force is given. We need to calculate velocity. How do we get the velocity? Velocity we have to get from force itself. That means if you get the force, you can calculate velocity. From force you will get you will be getting the from force what you will get, mass into acceleration. Okay, so in this question the value of mass is 2 kg. This is 2 kg mass. So now let us, velocity already know, means force is given, velocity we have to calculate, right? How do we calculate velocity? So if you take x component of force, this is 60, and y component of force is 60 square. This force is mass into acceleration, so 2 into acceleration along x-axis, 60. This is again mass into acceleration along y-axis, 60 square. So from here acceleration along x-axis is 3t, acceleration along y-axis is 3t square, right? Once you get acceleration, you can do the integration. Acceleration x is equal to dv by dt, right? So from here dv x is equal to ax dt. We can integrate, and what's the initial velocity? We can take the initial velocity to be 0, begins to move. So initial velocity is 0, and this is the final velocity along x-axis. So Vx will calculate by integrating 3t. So 3 comes out, the integration is t square by 2. So that means it is just 3t square by 2. That's the Vx, right? Similarly, Vy will calculate. So if you integrate same manner, Vy can be calculated as integration of Vy into dt. Ay is 3 t square. T square integration is t cube by 3. So this is just t cube. So now we know velocity vector. Velocity vector, which is Vx I cap plus Vy j cap, is now known to us 3 by 2 t square I cap plus t cube j cap. Right? Once you know this velocity, now we calculate power. Power is equal to force dot velocity. Let us just take dot product. You know how to take the dot product. So this is the component, right? 3 by 2 of this, and force is 60. So let's just multiply. What we'll get? We'll get 3 by 2 t square. T square also we have to take because this is also the component, right? So 3t square into 60 plus, now y component, same manner y component we can take. So this is the t cube and this is 60 square. So let's just multiply t cube into 6t square. So how much do we get? That will be the answer. So from here 2 into 3, right? 9t cube. 90 cube plus 6 to the power 5. Right, so let's check which can be matching. 90 cube, so 90 cube 6 to the power 5. This is the answer, correct answer, option 4. So I hope you have understood, right? These are the type of questions which are coming in JEE, and so definitely if you attend and if you listen the videos properly, you will be able to definitely solve questions and improve your score, right? Thank you for your attention. Then we'll see you next.